Okay guys, today we're going to do some of these velocity practice problems. We're still working on putting together information from a position time graph as well as pulling in the equation for velocity from your reference table, which is velocity equals change in position over change in time. So let's start, let me change the color here. Let's start with this first question. What's the average velocity for the car shown on the position versus time graph from 0 to 1 second? So from 0 to 1 second is only this segment of line. And if you remember what we've already learned, average velocity is the slope of this position time graph. So to calculate the velocity, I'm going to calculate the slope of the line. I'm going to take two positions. At 1 second, the car is located at 10 meters, and the initial position is 0 meters. And I'm going to divide that by the time, which is 1 second. You can go ahead and divide that out. You get 10 meters per 1 second. The units don't cancel each other out, so the average velocity is 10 meters per second. All right, so the next question's the exact same thing. What is the average velocity from 1 to 4 seconds? I'm actually going to change colors here. We'll go to the green. From 1 to 4 seconds is this segment here. So I'm going to calculate the slope. Well, you may already know by looking at the graph that this segment, a horizontal line, has a slope of 0. Well, if we do the calculation, you'll see why. At 4 seconds, the position of the object is 10 meters. And at 1 second, the location of the object is at 10 meters. So on the numerator of this slope calculation, I have 10 meters minus 10 meters, and the time span that I'm looking at is 4 seconds minus 1 second. So you end up with a slope of 0 meters over 3 seconds, which is simply 0 meters per second. Now in real time, what this would mean is that from 0 to 1 second, the car was moving forward from 0 to 10 meters, and then from 1 to 4 seconds, the car remained in the same location. It just sat in the same spot, is what that means. So then our third question is another average velocity question. What's the average velocity of the car from 0 to 4 seconds for the entire trip? Well, that's still a slope calculation, so don't let that fool you into thinking it's something different. We're going to take the final position, which is 10 meters at 4 seconds, and we're going to subtract its initial position of 0 meters at 0 seconds. And when you do that math, you get a fraction with a value of 10 meters in 4 seconds. And I always like to divide mine out into a decimal number. That gives me 2.5 meters per second. So it wants us to create a velocity graph for the car. Well, if velocity is the slope of position time, I'm going to have two different segments on this velocity time graph. I'm going to go back to the original colors that I used before. For the first segment from 0 to 1 second, we said that the slope of the position time graph was 10 meters per second. That means that this car moves at a velocity of 10 meters per second for 1 second. Then we said for the second piece of the position time graph, the green segment here from 1 to 4 seconds, the velocity was 0 meters per second. So on our velocity time graph, we are going to draw a velocity value of 0 until we get to 4 seconds. It doesn't really matter if you connect these segments with a vertical line, a dotted line, or no line at all, actually. But what I'm doing is the most important thing for you to understand. The slope of these position time graph segments becomes the values on the velocity time graph. So velocity is the slope of the position time graph. And so you can look back up here. Let me pick another color. this 10 meter per second slope corresponds to that. And I put the 10 meter per second value there. Okay. On the second segment, we had 0 meters per second for this slope here. And that 0 meter per second was my value from 1 to 4 seconds there. So you're graphing the value of the slope for the second graph that we just created, the velocity time graph. All right, and one final question. What is the instantaneous velocity for the car at 2 seconds? Well, here what we're going to do is use the graph. Look at your velocity time graph at 2 seconds, which is here. What is the velocity reading at 2 seconds? It seems to be 0 meters per second. So that question is not a difficult question, but you have to know which one of your graphs you want to read. So I'm going to encourage you to start looking closely at the y-axis. Oh gosh, I just moved a whole bunch of writing. Sorry about that. I was trying to highlight the velocity title here. I want you to look at the y-axis of your graphs before you start answering questions and doing calculations. All right, let's work on this next one. What is the average velocity for the truck shown from 0 to 2 seconds? Okay, so just like before, from 0 to 2 seconds is going to be this segment of the graph that I've highlighted in pink. The velocity is the slope of the position time graph. So the position at 2 seconds is 5 meters. And the initial position of the truck is 0 meters at 0 seconds. When we work that out, we get a fraction value of 5 meters per 2 seconds. And like I said, I divide those out. So I got 2.5 meters per second. That's the average velocity for the truck from 0 to 2 seconds. Now it's going to ask us to create this velocity time graph. So I'm going to take this slope value, 2.5 meters per second, and I'm going to graph that value here for a time of 2 seconds. Let's do the next piece. What is the average velocity of the truck from 2 to 4 seconds? That's going to be this segment that I'm highlighting in blue. So from 2 to 4 seconds, it looks like the truck moves faster because the line gets steeper. It has a larger slope. Let's calculate that slope to get average velocity. The position at 4 seconds, it seems to be 27.5 meters. And then we are going to use the position at 2 seconds as our other data point. It looks like it's at a position of 5 meters. And that happens at 2 seconds. So go ahead and grab your calculator. You can subtract this and you'll always have access to a calculator. You get the truck travels 22.5 meters in 2 seconds. And you can go ahead and divide that out if you want to. I got an average velocity of 11.25 meters per second. Now I'm going to want to take that slope, 11.25, and I'm going to come down here to my velocity time graph. And from 2 to 4 seconds, I'm going to need to graph a value of 11.25. This graph actually is cut off just a little bit, so you're going to need to draw your line. Let's see. Oh, until 4 seconds. I went a little bit too far. I'm going to cut it off. Let me erase right here. Oh gosh. Sorry about that, y'all. Okay, so stop your graph right there at 4 seconds. So that's a y value there of 11.25. Sorry, I cut your graph off on the worksheet too close. All right, the next question is to calculate the average velocity of the truck from 0 to 4 seconds. That's the entire time period that we watch this object move. So I'm still doing slope. look at the location or the position at 4 seconds. At 4 seconds, the truck is located at 27.5 meters. And the original position is 0 meters at 0 seconds. So you get an average velocity of 27.5 meters in 4 seconds. You can go ahead and divide that out. And you get 6.9 meters per second. I did a little bit of rounding there. Okay. So the instantaneous velocity for the truck at 1 second, we're going to use the velocity time graph. So go over here to your velocity time graph, look at the 1 second mark, and read the velocity from the y-axis. That is an average velocity of 2.5 meters per second. That's the answer for that question. All right, just a couple more here before we stop. Which vehicle, the car or the truck, has a larger average velocity from 0 to 4 seconds? Well, the truck that we just finished has a velocity of 6.9 meters per second. That's the answer to the question here. And if I slide back up to the car problem, we found out that the car has an average velocity of 2.5 meters per second. So I think my answer would then logically be the truck has a larger average velocity. And final question, which vehicle has a larger instantaneous velocity at t equals 3? Instantaneous just means at that instant or at that moment. So it's not looking at an average over time, it's looking at one specific second. So at 3 seconds, the truck has an instantaneous velocity. At 3 seconds, it was 11.25 meters per second. And for the car, we're going to have to scroll back up to that graph. At 3 seconds, the car has an instantaneous velocity of 0 meters per second. Remember, it was sitting still. So the truck also has a larger instantaneous velocity at 3 seconds. Okay. Now, that's a little bit different look to the problems. We've learned how to take the slope of the position time graph to create the velocity time graph. That's a new skill. But calculating the velocity as the slope of position time, you've already done. The comparison was a new type of question, so that might be a little bit new for you. What I want you to do right now is to stop this video, and I want you to try the problem on page 2. There's only one problem there. It's going to ask you some similar questions for an SUV that's traveling down the road. See what you can do with those, and then click into the module to look for the video where I've given you the answer to this, and see if you have any questions, and we'll talk about it next time. Good luck and thanks.